As the mysteries of the early universe pile up, a sobering question emerges. What if we're wrong? Not about the universe itself, but about how we're seeing it. The James Webb Space Telescope has given us stunning, paradigm-shifting images of ancient galaxies that shouldn't exist. Not this soon, not this massive, not this mature. But before rewriting the laws of physics, some astronomers are asking whether there's another explanation hiding in plain sight: cosmic illusion. Let's start with a phenomenon known as gravitational lensing. Predicted by Einstein's general theory of relativity, gravitational lensing occurs when a massive object, like a galaxy cluster, sits between us and a more distant object. The immense gravity of the intervening mass bends space-time, curving the path of light and magnifying the background object. It's like looking through a cosmic magnifying glass. Gravitational lensing can make distant galaxies appear brighter, larger, or even multiply their image. In extreme cases, it can take a faint, ordinary galaxy and make it look like a massive ancient behemoth. So, are the galaxies seen by JWST really as big and bright as they appear? Or are we looking at lens delusions? Some scientists argue that gravitational lensing could be responsible for at least a few of the impossible galaxies spotted so far. But this explanation has limits. Lensing leaves telltale signs, warped arcs, multiple images, and many of Webb's most stunning early galaxy candidates show no such distortions. Moreover, careful analysis has been done to rule out lensing in several key cases. These galaxies appear to be exactly what they seem: real, ancient, and massive. Still, illusion remains a possibility, but not just due to gravity. There's another factor: observational bias. Webb's field of view is narrow, and its early surveys focused on small patches of sky. What if, by sheer coincidence, we've stumbled upon a few extraordinarily early overachieving galaxies that don't represent the cosmic average? In other words, what if we're overreacting to cosmic outliers? It's a valid concern. Astronomy has a long history of jumping to conclusions based on limited data, only to refine the picture as more observations roll in. But the number of high redshift, mature galaxies JWST has detected is already well beyond what standard models predicted. These aren't isolated cases, they form a pattern. Even so, another potential illusion comes into play: cosmic mirages created by quantum effects. At the most fundamental level, space-time may not be smooth, but foamy, a turbulent sea of quantum fluctuations. Some speculative theories suggest that light traveling billions of years across this foamy structure might accumulate small shifts in energy or trajectory, causing distortions that mimic high redshift. If true, this could inflate the apparent distances and ages of galaxies we observe. Then there's the possibility of unknown intervening matter, clouds of gas or plasma that subtly shift the light's signature as it travels toward us. Could these distortions be making ordinary galaxies appear older or more distant than they truly are? Most mainstream astronomers remain cautious about these fringe ideas. But as JWST continues to send back data that challenges our models, more scientists are taking a second look at assumptions long held as fact. And let's not forget the role of our own instruments. Even a telescope as advanced as Webb must interpret the faintest whispers of ancient starlight. Every image is a data-rich mosaic stitched together from complex calibrations and filtering algorithms. A minor miscalculation in background subtraction or photometric fitting could skew a galaxy's estimated redshift, and therefore its perceived age and size. That's why spectroscopic confirmation is crucial. Already, multiple JWST targets have been verified using spectroscopy, affirming that their redshifts, and therefore their ancient origins, are indeed real. But not all candidates have been confirmed yet. Until they are, the door remains open to alternative interpretations. So are we witnessing a fundamental flaw in cosmology? Or are we simply being deceived by the cosmos, fooled by gravity, geometry, or even quantum trickery? The answer may be both. The universe is under no obligation to be easily understood. It speaks in light stretched across time, through space twisted by mass, through signals filtered by chance and dust and energy. Our job is to listen, not just with our instruments, but with imagination tempered by rigor. At Infinity Beyond, we embrace the possibility that the greatest mysteries aren't always what we see, but how we see. Every revelation from Webb is both a discovery and a challenge, a call to refine our vision. In the next segment, we'll explore how these cosmic revelations are shaking the very foundation of modern physics. From the constants of nature to the shape of the universe itself, nothing is immune to scrutiny. What if even the laws of physics evolved over time? What if reality is more flexible than we ever imagined?